Hello, everyone, and welcome to my talk on production experiences from computational reuse at Microsoft. Before we start, why do we care about reuse so much? Well, we all know that Perseverance is now on Mars, and one of the things it's doing is geocaching, where it's taking samples from the Mars surface and putting them in one place for further reuse in the future. As a result, future missions from Earth can go and fetch those samples and bring them back to Earth for scientists to analyze. However, we wouldn't expect every scientist to launch its own mission. Rather, we would expect a common mission to go and fetch all of those samples at once. We have a similar problem at Microsoft. We also have a Cosmos for doing big data analytics over shared input sets. And our analysis from millions of jobs and billions of subcomputations reveal that 75% of those subcomputations are overlapping. This is huge. And this happens because we are seeing an enterprise data pattern where people take telemetry from various sources and products, and they want to cook them into a shared data sets before they could be analyzed further by subsequent analysts. As an example, analysts may want to analyze things from Asia. They may want to compute different kinds of aggregates, for example, average sales, average discount, or total quantity sold from Asia. And when they write their queries, they may end up sharing portions of their query plans across each other without ever knowing. In fact, our analysis shows that more than 50% of the data sets on Cosmos are shared by at least 2 or more consumers. More than 10% are shared by at least 16 or more consumers. Seeing this huge sharing happening in Cosmos led us to think about how to automatically augment data cooking. And we have built a feature called Cloud Views for automatically materializing and reusing these common computations. We have made a bunch of interesting design choices here, which includes things like we want to preserve the query boundaries, but we want to automatically materialize the common computation as part of query execution. So we have the views stored online and just in time. Since we are only looking at the common computations, we also have accurate cost estimates. And we also have algorithms to do scalable view selection, and we can do very lightweight view matching. We also have a bunch of limitations. We are only doing exact match for now. We cannot handle concurrent queries because one query has to finish execution before subsequent ones can reuse. And we don't maintain the views, and we don't have their DDLs in the catalog. And we also have to manage user expectations. The end-to-end architecture looks a lot more complex. We start from this workload repository, which contains massive logs of past query plans. We analyze that in a scalable fashion to automatically identify the common computations. We feed those insights into an insight service, which orchestrates and which informs the query engine to automatically materialize and reuse in subsequent queries. Inside the engine, we have the logic for query rewriting. And then on top, we have various stakeholders to really keep in the loop and to stay informed as we do this automatic compute reuse. So once we go and deploy this architecture, let's see the impact we have had in production. So we looked at a 2-month window in 2020, and we analyzed a workload of around 250,000 jobs from over 600 production pipelines. And we saw that in this workload, more than 58,000 views were created, and almost 345,000 views were reused. And across a variety of metrics, we can see that we see significant improvements. Let's go into some of these now. First of all, if you look at the user experience, on the left side, we see the cumulative latency of the workload on different days. And we see over time, we see a substantial improvement once the feature was enabled. In fact, we saw 15% median improvement in the jobs latency. On the right, we are showing the cumulative processing time. And we see that the improvements here are actually even more significant, with up to 39% overall improvement, which is again significant for Cosmos workloads. Let's see about the cluster efficiency. On the left, we see that the need for opportunistic processing drops by 45% overall, which is nice because the jobs now don't need opportunistically spare resources and they have less variance. On the right, we see that the overall number of containers used reduced by 36%. Again, this is important because we now have less pressure on the resource manager. We also saw some non-obvious effects of computation reuse. On the left, we see that the total inputs read reduced by 39% because we are doing so much reuse, we don't have to read so much inputs anymore. Which is nice because we have now less pressure on the storage side. On the right, we see that the queuing time reduced by 13%. And this happens because the jobs are now smaller. So we have seen a significant impact in terms of performance, but we have also learned some valuable lessons from our experience. First of all, we saw a bunch of operational challenges, which includes things like that we have to be aware of the job schedule when we were trying to reuse computations. We have to take into account per customer expectations because they have different requirements for view selection. Since we use something called signatures for identifying and reusing computations, we have to ensure their correctness. We have to evolve them as the code changes evolves, which is sometimes hard. We have to take care of other dependencies in the stack. We have to handle things like GDPR and how to onboard customers. How do we opt in? How do we opt out? We have to also give them multi-level control. And finally, we have to measure impact, which is not easy because once you deploy something, the baseline now suddenly changes. And we have come a long way from research to production. We've also expanded to a broader workload optimization theme. We're looking at several projects in this area of how we can apply and learn from last workloads, which we have seen in the past. And we are also looking into areas such as how do we make the reuse more in general? How do we apply reuse across concurrent queries, apply reuse in other engines, and also other applications of reuse? To summarize, big data systems have really democratized scalable data processing. At the same time, data engineers often end up having pipelines which have significant overlaps across them. And thus, there's huge opportunities for improving operational efficiency. The challenge, however, is that it's hard to automatically identify these opportunities and to reuse them, especially in serverless infrastructures where the onus is on the service provider to handle most of these complex pieces. At the same time, we see huge opportunities to learn from super large workloads and huge opportunities to improve the efficiency in those workloads, which motivates significant monetary gains. So we have built cloud views for automatic computation reuse in Cosmos, and we have shipped and we have learned valuable lessons from the deployment process. This is also a super hot topic in industry at the moment, with several companies having various efforts in this space. With that, thank you so much, and thanks for listening to my talk.